Good afternoon, everybody, and welcome to this 3DI webinar. My name is Mees Rijs. I work for Nele & Schuurmans. And today we are very pleased to have so many people attending this webinar, where we focus on 3DI in the Danish context. Before we start, I would like to introduce some people that are on your screen right now. And those people are my colleagues Bram de Vries. He's a consultant at Nele & Schuurmans. Emiel Verstegen, he will be presenting the Tørring model today. He's also a consultant at Nele & Schuurmans. My other colleague Jonas van Sooyenstein, he's the product manager of 3DI. Then we have Morten Bonnenberg. He's an intern with us, and he's here to help you with any technical issues. If you experience them, please let us know via the chat. And we have Esben as well. Esben is joining us from Denmark. Esben is a consultant at NIRAS, and NIRAS is involved in the Hedenstad projects. So very pleased to have him on this webinar. And later on, Per Nørmark will also join this webinar. He works for the Hedenstad commune, and he will tell you a bit more about his experience. So then, to briefly introduce myself, my name is Mees Rijs. I work for Nele & Schuurmans. We developed the 3DI software, and we are expanding to different countries, including Denmark. I was involved myself in that strategy and execution. So we've been working in the Danish context, I think, for about 2 or 3 years now. And at this point, we have some good examples to show you what 3DI is capable of and how it's used in a Danish context. So we're very pleased with that, and very pleased to see many new faces as well here today. Well, then the 3DI is a hydrodynamic simulation software, and I think the challenges that we face in the Netherlands with regards to climate adaptation are very similar to the Danish challenges, and therefore I think it's one of the reasons why so many people attend this webinar, to see what the modeling capabilities are and how you can use 3DI also in interactive stakeholder sessions.
Well, first of all, I will give you a short introduction about 3DI. Well, when we developed 3DI, we said, okay, we have a certain vision when we develop 3DI. It's not only about new software, but we are looking at it and we see that the water challenges of today and tomorrow are solved together. The days where people are doing their studies of their hydrodynamic models and putting them all in reports are still there, but are declining. We see more and more shared decision making, in which the model is the design table, where stakeholders involved can verify and validate the value of their ideas. And from this vision, 3DI is developed with a focus on simulating, integral and interactive as a service with full transparency. Let me first get a bit more into 3DI, and then I will come back to these statements in this visions that will all come back. First of all, about 3DI, to clarify, 3DI is a state-of-the-art, cloud-based hydrodynamic modeling software solving the full symphony equations with conservation of mass and momentum. So it can be used for fluvial flood simulations. You can include the sewerage systems. You can include the groundwater in the wet situation, but also you can hook it up to operational models, and it can be used for flood forecasting. So when we developed 3DI, we started with it in 2010. New data became available in the Netherlands, which was the height model of the Netherlands, which was like 50 by 50 centimeters, which is almost similar to the Danish version you have now with 40 by 40 centimeters. And there was a huge potential for flood simulations to be done on this high resolution. However, current models could not cope with that. So then we got in touch with Professor Guus Stelling, He has been working with building these kind of hydrodynamic models his whole life, and he said, okay, I know a mathematician is a good friend of him in Italy. He has a new way of solving these water equations in a way faster way than is currently done, and also more accurate. And this is done with a methodology called subgrid, where you basically say the water level is gradual, but water depth can vary a bit. That is in flat areas like Denmark or the Netherlands. And in hilly areas, you can say that the water level is parallel to the slope or the incline. So with that assumption in mind, you can say that if you want to calculate the water, how the water level are going to develop, you can you don't have to calculate pixel by pixel, but you can, for example, take 4 by 4 pixels in one go, and even with taking all and without losing any accuracy, because that's just what the subgrid technology does, without going too much into detail how that works, you can calculate instead of this 4 by 4 pixels, which is 16 calculations it would otherwise be, you can do in one calculation. That can hugely improve the speed of the calculation. So this is all completely new background that is being used, a new engine, a calculation core, if you will. So it doesn't stop, of course, at 2D flood simulations. We have included the precipitation, the evapotranspiration, the wind, the infiltration, the groundwater, but also the sewage system, the control structures. Basically, anything that you can have in a water system is there, and you can use it in your calculations, and also, of course, with the groundwater in the wet situation. So yeah, if you want to build a 3DI model, you should see it, of course, as a digital representation of the real world, or as it's now called a lot, is a digital twin. The level of detail, of course, is dependent on the user. So how detailed do you want to have it? Do you want to have only flow on surface? Do you want to include river channel flow? Do you want to include sewage systems? Or do you want to include groundwater? It's good to mention that the 3DI calculation core is set up in such a way that everything, the water is calculated for these same areas, all in the same equations. We don't have separate modules that calculate the sewage system. We don't have a separate module that calculates the overland flow. This is all the same calculation core. And that makes it a high stable environment for your calculations, whether it be 2D, 1D, or 1D, 2D combined. Also, the model building we have done completely using GIS. QGIS is the core technology that is the basis on which you can build your model. And we have taken that and added our own tools on top of that to help users work with 3DI models and analyzing the results. So how would that work? Well, since we are working also with a large amount of data, we have set up 3DI in the cloud. So the calculation core, the running of the models is done in the cloud. The building of the models is done locally in the modeler interface. And if you're happy with your model, you can upload it or synchronize it with the cloud. No matter how you want to call it. And then it is available for the calculation core to run. You can do like a normal desktop study where you just start a calculation and then wait for it to finish and analyze the results locally. But you can also do it interactively using the 3DI live site. And but since we are using what is called an API, if you don't know what an API is, it doesn't matter. It basically means that you can interact with our calculation core the same way as our own software does. So for the scientifically inclined people, you can use Jupyter notebooks or your own scripting even if you want. But if you don't want to do that, you can also simply use the modeler interface and stay with that and do your calculations and your analysis. And because we have this API, you can also hook up operational models, and it opens up a wide range of possibilities. So in short, 3DI computes large areas on a high resolution thanks to the subgrid technology. we can compute the complete hydrological cycle. Whether you want to include everything, of course, is up to the user. The model building is fully GIS based. It's cloud-based hydrodynamic modeling software, and you can interact with your 3DI simulation in the browser. But also you can fully control and interact with your 3DI simulation using its open API. So you can also circumvent our own user interfaces and do it in your own way. So that is really, in short, my my presentation on what I want to share with you about 3DI. Of course, if you have any questions, this was only 15 minutes. There's way more to it. I'd be happy to answer any questions later on, or maybe in a separate call later. Let me know. I would now like to give the floor to Emil. He's going to talk about the application of 3DI in Hedestad, with particular attention to the Tørring area. I'm not really sure if I pronounced that right. Probably not, but my apologies for that.
Thank you, Janos. Thank you for the introduction of 3DI. Some time ago, we got a question from the Hedenstil commune because there were some issues with water nuisance in the region, with the question if we could facilitate them with some insight. They have some problems that they have high water levels in the rivers due to rainfall, and in the Tørring area there's specifically problems with sewer discharge of the rainwater sewer towards the rivers when the water levels are high. So they asked us to create a model that they could investigate the problem, and the model should include the rainfall runoff process, the river hydraulics, the sewerage hydraulics, and of course the interaction between them. So we can see the whole problem and also be able to find solutions wherever they can be. And the model has to be used for the assessment of the problem and finding mitigating measures, but also involving stakeholders by holding workshops and together taking a look at the model. And as Jonas just explained, there's a whole calculation core with a lot of mathematics under the hood. But what 3DI is also very good at is showing this in a simple way in an interactive live site. I would like to give a small demo about this live site in the for the Tørring model. So here you see the interactive live site. I've already searched for the Tørring model, and I can start my Tørring model with a click of mouse. And now somewhere in the cloud, a machine is starting, loading the model and initializing it. And soon it will give us a first overview of the model. It usually takes a couple of seconds, and then we will be able to start. There it is. So in front of you now you see the interactive live site. The most important element of this live site is the big map in front of you. You can zoom out for some overview, for some context where we are located. You can zoom in, pan around, and you will immediately see some elements that you can recognize as rivers. So we've modeled the rivers in this area, but also the sewerage system in the area is modeled. In the light blue lines you see the rainwater sewerage, and in the orange lines you see the mixed sewerage. There's structures as well in the model, for example culverts that pass under roads, bridges, What else do we have? We have pumping stations, for example, here at the sewage treatment plant. We have weirs, internal weirs in the sewage system, but also weirs in the rivers, if there are any there. We can, well, these are the one-dimensional elements that we have specifically modeled in this model. But of course, one of the big parts of this area and of the hydrological processes is the rainfall runoff process, and that we have done in two-dimensional with a digital elevation model. I open here my layer menu, and then I see that there's the 2D model raster available, digital elevation model. I can click it, I can evaluate it, and by just opening some layers, clicking around, you immediately get a little bit the feeling for the area. Where are the high parts, where are the low parts? And this is typically something you would like to do during a workshop, just have stakeholders involved in the area. How does it look? So we can interact with this model in a couple of ways. Here on the left, in the menu, we see several tools that we can use to apply forcing onto the model. The first one on top is the discharge tool, which we can use to add a certain discharge wherever we want in the model. So, for example, if we want to calculate what a pipe burst of a water main does to your city, we can just add water a certain amount of discharge for a certain amount of time. We can do the exactly the same thing with the pump tool, but it's the reverse. So we can remove a certain amount of discharge for a certain amount of time. For example, if you encounter flooding and you want to investigate if placing an emergency pump would be of any help or not, you could use this tool. We have the rain tool, which we will use in this demo. We can add some constant rain event to the model. For example, in this case, I would like to add 30 millimeters per hour for duration of 2 hours. So I can create this rain event. I can see on the bottom that it is added. It will be applied to the model. So this is one way of adding rain. Another way of adding rain is radar rain. We have currently connected the Dutch rain radar to 3DI, so we can select any date in the last at least 10 years, and of that date we will get the spatial temporal rainfall data, which can be applied immediately to the model. But there are also design rains, standard rain events that we use in many studies. So I've just applied the rain. We also can apply wind to the model, any direction, strength. If you want it, you can just add it. And we can edit the digital elevation model as we go. I will not do this for now, but maybe later. So I have added the rainfall event to the model. And I can start my model by just clicking the play button. You don't have to specify the rain event at the start of the model. You can pause the model anytime you want and then change the rain event or extra rain event. On the top, you see the clock. It's ticking. You see here the hours and minutes. So we're now a couple of minutes into the simulation. and immediately you will see the white dots moving over the channel and over the through the sewage pipes. So of course the sewage pipes are first filling up before they really start discharging in a fixed direction. But after a while, you can immediately start seeing patterns. Flow originates from where and where does it go. So we can, for example, see that this flow here is being split into two branches. And in the end, it is discharged in 2 points. So you can imagine if you apply this model in a workshop setting, if there's a residential development taking place in this currently rural area, how could it potentially influence water nuisance upstream in current residential areas? We can take a look at a pipe. If we click it, we can relive as the calculation goes, see the results. On the top graph, we see the velocity in the pipe. In the bottom graph, we see the discharge in the pipe. So we can view the model results as we are modeling. So you can view discharges, but also water levels. For example, in this river, well, we see first a small increase in water level as the model initializes, but at the moment the water level is currently dropping. It's just raining for a bit, so there's no big inflow of rainwater yet into this river. On the two-dimensional plane, we see water puddles being created. For example, up here, we see a stream here. I will show first on the aerial photograph. You can see a stream. This is also clear in the digital elevation model. And as Jonas just indicated with the subgrid technique, we can take this high detailed information into account even with a bit larger model grid. So I can show the model grid that we have used in this model. You can see that it is finer in certain areas and larger in other areas. As a modeler, you are completely free to make your own choices where you want which size grid. But if we take a look then at the water depth, we see that it is actually on a way higher detail than the model grid. So we can also take a look at these water levels here. For example, in this puddle, we can see what the water level has been during the simulation. But also we can take make a line cross section and take a look at the results over that line. Let me pause the simulation for a moment because we're missing the interesting part. Maybe it's a bit. So here we see the water in the channel being placed, and as we go in the simulation, we also see it being updated in the graph. So, well, it has been raining now quite a lot for 1 hour. Let's go a little bit back to the urban area. What we can see is that the water level is not dropping anymore, and it slowly starts to rise. We see here on the left quite a big puddle of water being created, and this is all coming down the river through the urban area. And you can imagine this can start to cause some nuisance. So if we continue the calculation now, we see a sharp increase in water level in the river. And well, one thing is that it can, of course, top out over the embankment, but also the rainwater sewage, which is discharging onto this canal, can be limited due to the high water levels. So if I take a look at this this pipe, we see already that the discharge in this pipe flowing into the river is decreasing. So what can we do against this? If we have the ability to intervene in the water system, we can, for example, close off this culvert going under the road. If we take a look at the digital elevation model again, we see that it is actually quite a nice barrier. There's a wide valley, so if we can use this area as a storage, that would be nice. So there's not a big inflow of water into the urban area. So let's take a closer look on this culvert. Well, we see here the discharge increasing. Well, the graph shows negative values here, but that depends on the direction of flow. So there's now, it's going up to 10 cubic meter per second. So that's quite an inflow that we want to stop. So let's first take a look at the details of this culvert. This menu gives us a little bit more information. It's quite a wide culvert with 5 meters width. It's a circular culvert and it has a start and end height around 56, 57 meter mean sea level. And when we can edit this culvert and say, okay, I want to close the culvert completely up. So I say, okay, I want to close it. I confirm my choice, and it now says status closed. If I now continue my simulation in the next time step of the simulation, you see immediately the velocity and the discharge go back to 0. The dots stop moving. And if we look further down the road in this canal, we should see a sudden decrease of water level because there's no inflow in the channel anymore. So the discharge in this channel is suddenly decreasing. See, it goes back to 0 again. And also, if I select again this pipe where the discharge was just decreasing, we see all of a sudden there is much more discharge possible because the water level in the river has dropped quite a lot. Well, we have solved one problem maybe in the city, but there's quite a lot of water being stored here. I'm not sure what kind of crops are harvested on this field, but maybe we want to limit the amount of area that has been inundated. If we create the opportunity to close this culvert, maybe we can combine it but with creating a water buffer around this channel. So for this, we can use the raster edit tool to lower the digital elevation model here to create a buffer. Well, let's first take a look with our cross-section tool what the elevation more or less is and what the water level is. So we see water level, a surface level of around 58.5 meters, and there's quite a big puddle of water standing there at the moment. So let's create a new elevation of 57 meters. I can now draw on the map where I envision this rainwater buffer. And I close the polygon. I confirm that this is my choice, and I continue my simulation again. Now, of course, the ground just drops away from under the water, so the water needs to redistribute a bit and need to flow into the big storage facility that we have created. But you see that the water is immediately disappearing. It still needs to flow out into this hole. But by doing this, we immediately can get a feel like, okay, how big can we make this storage facility, and what's the influence of it on our problem? So it's really fast in just getting a feel for these mitigating measures. So this, I think I've demonstrated most capabilities of the live site. As Jonas said, the live site is one of the ways to interact with your model. From the modeler interface, the QGIS expert environment, let's call it like that. There's other ways of interaction, and if you like some programming with Open API, there's even more abilities to interact with your model. But I think for workshops, for getting a quick insight into your model, and for actually quite a lot of analysis, this way of modeling gives you already a lot of tools to execute your studies.
Yes, thanks, Emil. Thanks very much. Then I would like to now go to Per Nurmark. He's a panelist on this webinar and works for the Hedensted commune.
Yes, thank you, Mish, for inviting me. And as Emil has just shown that how the model is working, and I think in a very visual way, he has shown that when you are working with stakeholders, it's a very visual and doable tool for making the flood and the flood system both on the surface and on the surface for visual for the stakeholders, and that is also one of the areas that we have used the model for visualization of the where do the water goes and where does it come from. Yes.
Mm-hmm. Because Per, can you tell us a bit about, because there are a number of projects in Hedensted, can you tell us a little bit about those different projects that you are currently involved in?
Yes, we have the 3DI model in 3 of our areas. It's part of the Coast to Coast project, cooperation project in the region of Jutland, and we have the model in 3 areas. One in Tørring, as we say in Danish, and we have in Hedensted, and we have in the Hope to Hope, the Juelsminde område. So we have in 3 different areas. The last one, Hope to Hope, the Juelsminde area is a very rural area with small cities, but open land, big rivers. The Hedensted and Tørring is a city area more or less, and flat in Hedensted and more sloped areas in Tørring.
Yeah, and can you tell us a little bit, because each area has different challenges, I assume, therefore there are different models. Can you tell us a little bit about the challenges that you and the community are facing or are expecting to be facing over the coming years?
Yes, both in Hedensted and in Tørring, the city of Hedensted and Tørring is the center area, because it's both very important for our municipality to be able to develop both cities. It's very central for us that the development, the citizens should be able to live there and to to live there. The other area, the Juelsminde area, it's a very open area, but there we have farmers, nature people, and so on. They want to be there. We also have a large summer cottage area. It's very important for us. So Hedensted and Tørring are more or less the same problems. City where we should be able to develop, and the Juelsminde is a very rural area where also we have development as an issue.
Yeah, and therefore using 3DI, what kind of simulations do you run, and how do you involve the different stakeholders?
We have in cooperation with NEOS, we have the model built up for the three areas, and we have both the sewage system, the rivers, and a little bit of the groundwater, but that was not that much at that time. We bought the model, but I think you have built a lot of things into it afterwards. So we have both the rivers, the sewage systems, the surface, and one of the main point is that when you use the model in a more or less live situation, as Emil had showed here, you can make a discussion with the people. Is that where you see the water, or is it the other way? And if it is the other way or the area, you have to change something, some parameters. But we have experienced a lot of times that when we show the model in a live situation, they say, "Oh, what is that? Okay, that's where the water are running," and then we can talk about what should we then do if the water should not run there but in another place. How can we stop the water? What kind of scenario will they prefer that we build in?
Yeah. So if I understand you correctly, it's very important to create trust with the different stakeholders. That the situation that you are simulating is actually something that they also recognize from personal experience, isn't it?
Yes, we ask them every time we show the model for the first time, is that what you see? Is that what your kind of reality? And if they say no, okay, we have to change something. What do we have to change? But I'll say that especially one situation, they say, what is that? And we say, oh, that's a mistake. No, it's not a mistake, because we have a river, then a pipe, and then a river. And that was correct. They say, we know that.
Mm-hmm. So they also help you maybe in some ways that with their experience to help improve the model, keep it accurate.
Yes.
And when it comes to mitigation, what kind of ideas come up, or what kind of suggestions do you put out there, or what kind of suggestions come up from these stakeholders as to how to tackle issues?
More or less, one of the issues that they will always suggest is what Emil showed, that we should hold back the water from the river systems before running into the town. And what's then is the problem that we have to make an appointment with farmers. So is that okay? And we can talk with the farmers. how big area and what should we pay for the water to run there.
Yeah, and if you wouldn't have this kind of visual representation, how much more difficult, or would it be, or would it be easier, or what do you think if it wasn't for this tool, how would you, what is the difference, let's say, compared to an old situation and using this tool?
Yes, one of the strengths about the model is that it shows that the areas are connected. So if because one of the we can talk with people without the model, yes, we can do that, but they always suggest that the solution should be outside the area, and then we say, okay, we'll build a storage capacity outside the area, but that's your neighbor who you are hustling now. And is that okay? No, it's not okay. Where should we then put the water? So you are able to talk with the people in connection with the whole society or the whole strength of the river or the sewage systems or whatever.
Yeah, it sounds like the not in my backyard principle that comes up a lot of the times when you want to make any adjustments, right?
Yeah.
Not in my backyard.
Not in my backyard, and in one of the session, a man he suggested dig some holes, and we couldn't make him understand that it's not a solution. But then we can show by digging some holes in the model, this does not solve the problem. Okay, then we'll stop talking about digging the hole. Oh, yeah. Okay, then go further. But then
it's a lot about the acceptance, social. So there's the technical aspect of how do consultants, and Niras has helped you a great deal with that.
Yes.
What are the suggestions from technical experts? But then to get those accepted is another issue, isn't it?
Yeah, and I will say that from the first workshop we hold to or participate in together with Niras to what I have just seen, the model are pretty fast now, faster than the first time, because at that time it was a little bit slow. Now it's fast.
Yeah,
even faster.
And I think that's a good point that you mentioned there. That's also something that we're trying to make people aware of, that this is not something you can use just for a one-time project. You should keep this up to date and
yes,
open this, and now it's easy to access as well. So you can really use it in any project or within any situation where you think this would be helpful. To create the support from the community.
Yes.
Okay. Thank you, Per. Okay. Can I ask Esben? Hi, Esben.
Hi.
Because Esben, you are a senior project leader at Niras, and you've been involved in these projects. Can you tell us a little bit how you got into contact with 3DI and what your experience has been so far?
Well, our experience came because we were invited to one of these coast-to-coast initiatives where Hedensted, together with Tørring, where actually it was Tørring who came with 3DI first products and showed it to Hedensted municipality, and it fit very well to this regional project coast to coast. And because we had some connections to the municipality in different ways, they asked us if we knew this software. And when the software was shown at one of these meetings with Tørring, we thought with the objectives to involve stakeholders in finding solutions, this software was stronger than the softwares which we knew at the present time. So we pushed forward that we would use this software as a solution software, or a software to find solutions for both the coastal issues related to Juelsminde and the more city issues related to rainfall events. And I think this software showed its potentials, but also showed their where was it difficult to apply in a Danish context, from my point of view.
Yeah, thank you. Meanwhile, I see some questions coming in that I think would be good to address. We have a question coming in, and I would like to ask my colleagues to turn their webcams on as well, so I can ask any one of you to answer this question. Is weather data from DMI, the Danish Weather Institute, also used in our model? Who would like to respond?
I think it depends on. I don't know if it is used in that sense that the rainfall radar, as Emil showed, is being used. But I guess the precipitation as it went, like a standard graph with a uniform rainfall event, might have been used. I'm not sure. Can you answer that, Emil?
I believe some custom rain events have been used. So we determined what kind of intensities and duration of rainfall needed to be used for the Danish case. But we didn't use spatial temporal radar information from the Danish Weather Institute. It is technically it is possible to use radar data from Denmark and upload it to the model and use it.
Yeah, we have with the version that we are currently having, that is also way easier. It has become, and you can also, if you can supply it in the right format that is used for these kind of data, then you can also just upload these files yourself, and you can have like a radar rainfall event on your simulation. So it is not used in the model as such now, but it can be.
Yeah. Esben, can you, I think, isn't it the case that the Danish Weather Institute is making this data public, and that is a project that they're working on over the coming years? Is that correct?
I'm not quite sure. Maybe Lene, my colleague, who's also on this webcast, can answer that.
Yeah, I think that's something that they're working on, and if it is available, or you know that it's available, please let us know, because then we can also include that into the software. I think that would be much easier for users as well. So currently you can upload a kind of a text file, as Emil said, with in which you put the rainfall event in that you want. But it would be ideal to have it hooked up to the Danish rainfall radar. Okay, I'll go to the next question. Jonas, there's one for you, I think. Is it possible to record or make a movie of the simulation?
Yes, you can record your screen, of course. I'm not sure, probably that's not what meant, but you can use software to record your screen when you make the simulation, and then you have a movie. It is good to know that with the current version of 3DI that you just saw, this live site, for people that have seen it in the past, it has been changed. It has a completely new look and feel, that we are seeing in the background. We have all the information, all the metadata available to do a potential rerun, but it is not possible yet to do a complete rerun of the simulation in the live site as such. But you can, of course, make a movie or record it with external software.
Yeah, and maybe to add to that, with a 3DI subscription, there are packages of simulation hours included. And we have designed these packages so that You can run either one project or multiple projects, and you have enough hours to run the same simulations or variations to the scenario that you are that is your initial scenario. So that's I think also good to know. I go to
sorry to interrupt you. One last addition to that regarding the simulation hours. We have now also we are reviewing our subscription model, and we are, because we see that people also want to know on beforehand a bit what they're going to spend. We are also going to have people the option to go for unlimited rainfall calculation hours. So that is new. That is also because we are dedicated to make the models run as fast as possible. We want to show that to you, and also by giving this as an option in your subscription, you don't have to worry about calculation hours at all.
Yeah. Okay, then I have another question here. Is it possible to illustrate the flow path on the surface, for example, using flow arrows? And how about the width of the flow paths? How much area does the flow on the surface need? Is it possible to illustrate that? I think, Emil, that is something that you might be able to answer, or Bram.
Yeah, I can answer this. Well, the result of a 3DI model is a GIS file where all the for every time step, for every calculation cell, you have information about the flow, which direction, and the amount of discharge. And there are tools that you can use to illustrate this data. Maybe I can show a small example. My screen. 1 second. Thank you, nice. You see my screen now?
Sure. Yes.
So there are numerous ways you can visualize. I think this is the most fitting answering your question. You can see here the overland flow in a more rough view on the left, or on the right, a very detailed view in the city. How does it flow over the surface? So you're free to take this GIS file format and visualize it in the way you want it yourself.
Yeah, and maybe to add to that, I know this comes from an engineer with a lot of modeling experiences, and something he probably does a lot in his analysis, and something Nilas also does a lot, I guess, Esben. Yeah. So if you'd like to know more,
yeah.
Yeah.
There are also other tools available also with QGIS by now to do it in a native way, because our NetCDF is supported by the mesh layer from QGIS itself. There is native support to make these kind of tracer movies, for example. And I think there's also a difference maybe between 2D and 1D flow. But for sure, it is possible what is being asked here, although not maybe on the live side directly.
Yeah. Okay. And if you'd like to know more, I would like to invite you to get in touch, and we can demonstrate that in a short 15 minutes or something to you. Okay. Let me check if any other questions have come up. I see a reaction from Dorte, colleague of Esben. DMI's radar data will be free during this year, actually. So something to incorporate, Dorte and Esben, into 3DI, so to make it easier for all the Danish users out there. Okay. Then I think we've run out of questions, and we're running out of time. Well, I think we've done quite well, 2 minutes to spare. So that leaves me to thank all of the presenters, and especially the Danish here in the meeting. Per, thank you so much for joining us during your holiday times. So very much appreciated. And we look forward to helping you, and together with Miras, in making the projects, climate adaptation projects, into a success over the coming years. And Esben, thanks also for joining us here. And if you have any questions, by the way, to Per or to Esben, I think you're free to reach out to them as well. I'll include their email addresses in the email that you will receive. And then also thanks to my colleagues, and thanks to all of you for joining us today. A couple of things to end with. I would say if you're interested in, let me share my screen. Did that work? Yes. If you're interested in knowing a bit more about the technical side of 3DI, you can go into the docs. We will include these links in the email, by the way, as well. We have a LinkedIn showcase page on which we regularly post a bit more about the projects that we are taking on with 3DI. So that is something to keep an eye on, perhaps. And then also keep an eye on our blog page on our website for any further webinars upcoming. We are planning to do another webinar in which we highlight the Tiburon case, and we hope to host that in a month or two. So look forward to seeing you there, and thanks for now. Goodbye.